I would ask you to go again to my repository. So now I also uploaded this machine learning.pdf, which is the slides that you can download and you can just check if you want. And we should go to the hands-on here, like the last one. And I will open it locally, as always. Okay, so let's go to the top. This really distracts me. Okay, so again, we're gonna work with the matter power spectrum. So class 0, this is for some reason not working. Does it work? Yeah, okay. So class 0 is going to be our baseline lambda CDM standard, and class 1 is going to be a particular non-standard power spectrum. So first of all, we need to generate the data. So let's import the packages again. And then we need to just simulate the more or less the shape of the power spectrum, like the baseline, which is the lambda CDM, and then the second one, where is it? Yeah. So this is going to be the lambda CDM power spectrum function, and this is going to be like some non-standard feature with an oscillatory pattern, more or less, but it's going to be very subtle, so you're not going to be able to see it by eye in principle. So we run the functions. I mean, if you want to check them carefully, you can maybe do so later, but so far we just need the data. More or less, we're going to obtain something like this. Yeah, we plot the baseline is in blue, lambda CDM, and then this non-trivial oscillations, which is going to be our feature model. And then, okay, we just visualize it, but now we need to generate the full data set. And we are also incorporating some noise. Where is my noise? Ah, here, noise fraction. So I set it to 0.05, but you can play with it if you want, like later when you have time, when you're bored at home. You can increase this noise, decrease the noise, see what is the impact on the noise. And we are simulating 3,000 realizations. Okay, and this is your tasks. These are your tasks. So the first one, I would like you, okay, this is very easy. You just have to split the whole data set into training and validation. And then you need to build or try to build a neural network classifier. So remember, like with the previous notebooks, you can check, you can, if you want, you can just copy paste, but try to, I don't know, add different amounts of neurons in the layers. So you can do that. The second task, just try to compile a neural network and try to train it. And then, okay, maybe let's stop there. So start. Maybe we can 10 minutes? Yeah, is 10 minutes okay? Okay. So you let me know if you have any any question or doubt or and if somebody has it, just raise your hand. So it's free, you can build the neural network as you want, you can set the amounts of epochs that you want. Me toca. Sonrían. Mm. Si alguien ha obtenido algo, puede levantar la mano si quieren. Okay, okay. Ah, yeah, sorry, I'm switched to Spanish immediately, like without. I'm sorry. Tell me. The batch size, it's like usually set to 32 or 64. Yeah. Ah, yes, yes. So like 32, like say you have 1,000 realizations, so you take the first 32, you pass it, and then the next 32, and you pass it. So that's the batch size. Yeah, yeah. Sorry if I didn't explain it very well before. Yeah, I'm sorry. So you have to do only until the task 2, eh? We're gonna do the rest. Okay, good. Just to. Ah, yeah. No, like you. Ah, yeah, yeah, yeah. Because it's I think this one is 3,000, no? Like here, 3,000? Ah, yes, sorry, sorry, sorry. Yeah, let me check. So we have 3,000 sorry, 3,000 realizations, and we have 200 points. Yes. So it should be 200, yes. Although, let me check. Uh, it should be, there it is, the baseline. Yeah, you can do this, like input theme and reshape. Maybe I didn't say it, I didn't say this part. So like you need to reshape the input data so that the neural network can take it. So you just add one dimensionality. So if you have, for example, for example, if you have an array, like you have a number, comma another number, comma another number, you have one dimensionality with this reshape, doing like a list of lists, something like that. So that reshape is for doing this. Sorry, I didn't explain it.
I copied it from the example.
Yeah.
It's
not working?
Example.
It's not working?
Sorry. In the second, in the two, sorry, the file that is called 02 neural network.
This one.
After the definition of the training set and the
This, no? Input shape. Yeah, maybe use the 03 CMB example. And here there is this input dim. And there is this X train that you can shape. So like you take the shape of the training set so that you don't have to put it by hand. So you extract the shape. So maybe you can use this. Let me know if it works, because okay.
One question, the alpha parameter, the 1 to the minus 3,
Yes.
is relative to the values of the parameters that we are fitting.
So this is a hyperparameter of the neural network. So you are, how do you say, increasing or decreasing the learning rate, which is this step that I was saying before. It was something like this, right? So you are going down. So this alpha parameter, it's the learning rate that basically tells you how big are your steps to explore this global minimum.
But if the parameters, the number that we're using with the parameters, let's say it's to the order of 10 to the 6,
It's 10
relative to the
no, I think this one, you usually like people use 10 to the minus 3 because it also kind of updates. Like if it finds a minimum, then it starts to reduce, you know? And if it doesn't find a minimum, it's kind of big.
Okay.
So especially if you use this optimizer, which is called Adam.
Okay.
So if you use Adam, then by default, this alpha parameter auto-tunes. Like it is, yeah. So you can start with 10 to the minus 3.
Okay, I was thinking that maybe if the values were too high, 10 to the minus 3 could be
Too small. No, because you are exploring the minimum of the loss function, so it's not so. It is?
Because if your
Connected.
parameter range was big and you're like moving across the parameter space, I saw that it could be a problem.
Like usually you want it to be small, but not so small.
Okay.
Yes. Like 10 to the minus 3 is okay. Yeah. ¿Y nada? Sorry. Sorry, I thought that you were still training and there was some problems. Like, oh my God. Who has it? Can somebody raise their hand? Does somebody need help? I can just go around. But I don't want to intimidate anyone.
I am comparing the two numbers. In the first one, you decided to go down, and the second one makes in this I was copying from that.
Esto es como yo le doy 32. La mitad de los se repite. Creo que
Sí, pero
estos son los certificados un poco bastante. Sí, pero no sé.
pero es que no quería tener. No quería tener.
Voy a tener.
Porque quería no estar viendo.
Puedes ponerte el timer.
No te engañando.
¿Qué hacer? Sí, sí, sí.
0.53. Puede ser incremento a 100. Oh, no. 23, 25. Y los function van cayendo como esto. No, no, ni los function está como. Oye, qué loco, ¿cómo te llevas?
Ahí lo recibo. Eso me llama la atención. Eso la
¿Sí? ¿Qué está muy loco?
Ya, sí, sí. Es
0,76.
No, está bien, me pareció
¿Cuánto fuiste tú? 76.
O sea, puede
La cámara no.
solo tiene 64 capaz, o sea, pueden y de verdad no funciona.
Oye, pero no.
Vamos a entrar. Sí, 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 vaya Martina. Ahora no sé.
No.
Si alguien necesita mi ayuda, estoy por aquí.
El, can I lower the touch point and it decrease the accuracy?
Okay.
Is that normal? Do you want to have high accuracy?
It depends on the problem. So sometimes people say that it's like an artisanal work because you need to fine tune to see. Yeah, but I think the usual is to use 32 or 64. That's the usual. Yes. So how is it going? Did you train? Yes?
Neurons and maybe.
When we increase the number of neurons, we have to learn to build this argument of shape.
I don't know. No, it's only for the input layer. Only for the input layer. The input shape is only for the input layer. Okay. So can somebody tell me what is going on? Like, did you manage to train? Do you have good results or not good results? Who has not so good results? One, I heard Domenico too. Three here. Who has good results, really good results, like a super high accuracy, a very low loss? No? Nobody? Okay. This is actually supposed to be. Now I'm going to explain you why. Yeah, sorry. There is a message in the thank you. Yeah. Sorry. So you actually did, okay. So you actually did train the model. Okay, I'm also gonna do the same. I'm gonna split this, okay? I'm gonna clear the session, as I told you that is important, and I'm gonna train my, okay, I just use this architecture, whatever. And did you also evaluate the curves? No, we said only until the second, right? Sorry. Okay. Okay. Can you actually do the third part? The learning curves, plot the rock and the AUC and the confusion matrix? Can you try? And you tell me what you see. So in my case, just a second. Yeah, okay. I won't show you the solution. Not yet, at least.
Question, if we have 64 neurons, and we have a batch size of that's the nature of using all the input data for the
Yes, yes, I think it makes sense.
one data.
The thing is that you use one data per neuron, yes. So we have 64, right? I think you just take maybe the next batch if you have 64 and you have a batch size of 32, right? So it just takes maybe the next batch as well, like the 2 batches and then the next 2 batches. But I'm not completely sure about this. Also. Yeah, I'm not completely sure. I can wait. Yeah, sorry. Just give me a second.
Sí, siento que sí, la reforma bajaría.
Does somebody, did somebody get the plots? Do you want to share on Zoom? Okay. I'll stop sharing. Ah, sorry. Someone is asking. I got a strange result. Is it normal? It's a line in mirror. Is that you, Master? Okay. Okay, guys. So we're gonna see the plots of Jordan. I mean, it's a voluntary work. If somebody wants to show, you can show. If not, it's okay. Okay, so yeah, right? Yeah, the accuracy is going weird.
And it's the condition.
Yeah, so you can see that you have 198 points that belong to class lambda CDM were correctly classified, but 166, which is of the same order. I don't know if you can see. It's you can also connect on Zoom. Okay, so here it says 198. Yeah, thank you. Thank you. Good. So it's 198 and 166. So these are being misclassified, right? Like of class lambda CDM, these are being misclassified as the alternative model. Okay, this one, okay, but 72 is also. And what about do you have the other? Okay, cool, thanks. So here you have 0.67. You should be closer to 1. And this is like just a random classifier. So you see that we are a little bit above that random classifier, right? So again, it's good to see all these plots so that you can actually realize that not everything works at first, right? Okay, and I think it was all. Was there one more plot? No, that was all, right? We checked everything. Okay, thank you. Okay, so now I will go back to sharing again. Okay, so the task 4 says, okay, yeah, the task 4 says what happens if you change the batch size. I think, Charlie, you made the attempt of changing the batch size, maybe?
Yes.
And what happened?
And when I decrease it, the accuracy went down a lot. When I increase it to 100, it reached to, well, it went higher, like 70.
Okay, 70, but then it didn't increase more.
Yeah, no, it didn't.
Okay. Yeah, so you can also, this means that you also need to fine tune the batch size because it means that it's the amount of data that the neural network is seeing at the same time, you see? So if it's too much, it would be, probably it would get like, I don't know, overwhelmed, let's say. And if it's too little, then it's not going to be enough. So you also need to fine tune it. But let's say that a good practice is to use 64. I don't know if I wrote 64. I know I didn't write, you wrote it yourself, right? But okay, so, and this is the task number 5 that I wanted you to do, which is to normalize the input. Do you remember that we were discussing at some point, and I told you that you were going to do that, not me, which was the normalization. So in principle, if we have, maybe I can use the board. Yeah. Okay, actually, this is good. If we have some feature like that, it's, let's say, bigger than the baseline model, we need, like, how can I explain? Wait, just a second. Yeah, okay, maybe this plot is better. So we need to normalize it so that we can make these differences bigger. I don't know if that makes sense. So in our case, probably the neural network is seeing these differences as very small, and we need to pass all the data, like to normalize it with the minimum and the maximum, but of all the data set. Because it could be that one realization has like a very big difference and another realization has a very small difference. So you need to normalize all these things so that you can have like a more standardizable like feature that you can detect with your architecture. I don't know if that makes sense. Does it make sense? Yes? Sure? So the idea is that go again to your notebook, and here I wrote that you can use this standard scalar and retrain the model. How to use it? Okay. You call it like this, standard scalar, and I think you need to import it in scikit-learn. Should be somewhere here. Wait, sorry. Yeah, look. You need to import it from the scikit-learn, and then you use it. Where is it? And then you use it like this. You call it standard scalar. Can you see? I don't know why I cannot zoom it in. Yeah, sorry. So it says scalar equals to standard scalar and the brackets. And then you use this scalar fit transform, which is this is like a function from scalar. So you transform all your training data set. Can you see? What about there? No? Can you connect to the Zoom link? I cannot. No, yeah, okay, I have an idea. No, I don't. I always try to zoom here and I can't. Zoom. Sí. Command más. Ah, thank you. Obviously not used to Mac. Okay. So we were task 2, here. So first you need to import it. So you say from TensorFlow dot. Okay, let's go. So from scikit-learn dot preprocessing, import the standard scalar. So this is going to be our function that is going to normalize our full training dataset. And once you have done it, if you have not done it yet, please do so. I'm gonna go down. Yes, okay. And once you do that, call it. You call it. And then this scalar, like this standard fit transform. So it takes the full training data set and takes the minimum and the maximum and standardize all the rest of the data realizations. So you import it, you call it, you use this fit transform property, and also, yeah, the same down for the validation. So once you do that, I mean, call it a bit different, like first we did the training and validation split, right? So once you have done that, you apply the standard scalar fit transform function. And yeah, then you have to train again. You have to redo all the process, but this time, instead of just training with xtrain, you have to train with xtrain / the new training. I called it xtrain, yeah, / how do you call this? ¿Cómo se llama? Guión bajo. Underscore, thanks. Underscore S. So please do so and let me know when you finish. And if you need help, please raise your hand and I will go to you.
The argument of stratify what it means.
I always say stratify, yes. I don't remember. Sorry, but let me check. Yes, yes, yes. Mm. Okay, yeah, I forgot. It's to match the like you are defining a random state, right? This it's to match the same label to the same X train. So that if you're taking randomly any data point, let's say the data that okay, not data point, but data realization number 100 to be the first one in your training set, in your new training set, then you take the same label at the same place and you take it in your new Y label. So to match the X train with the labels. Does that make sense?
I suppose that
It was already by default. Me too. I mean, if Google is correct, based on the unique values of the chosen variable, yeah. Ah, sorry. No. I was wrong. Sorry. Okay, so I think this is for the class imbalance that you were saying. That if you have, say, 70% of one class and 30% of the other, if you are taking like a training set and a test set from those data, that you're going to have the same 70 and 30 in the training set and in the test set, so that they will be equally represented in both. Yeah, that's it. Sorry. I always just write it and I forgot. Thanks. That did somebody already train? Yes? Can you raise your hands who have already trained? Just you don't have to do it a lot. You can just shyly, yes, thank you. Just for me to see. So, how is it going? Okay, so what can you say about the normalization? Seems to be important, right? Okay. Hmm? Yeah? Can I see? Yeah, so you are training not on the you need to train on the new exactly. And also I think this one doesn't yeah, it does need to be normalized, right? But you also yeah. here, exactly, the validation, and then the white train doesn't, carry, yeah, exactly, yeah. And then this doesn't carry, yeah. So now you need to retrain.
That is separation.
Oh, wow.
Accuracy, like. What
Is the, can I go, look, you are also training with the previous one.
like the
With the, yeah.
Oh, yes.
So don't forget to change when you do the whole normalization, you are calling it a new variable. So don't forget that when you do the model fit, you also need to put x train down slash s because it is a new x train, right? After normalization. Don't forget to change that. I also missed it many times, eh?
Oh my goodness.
Yeah, exactly. So so this, I'm saying this, don't forget this x train down slash s and also changing the validation.
Accuracy.
Can you see now? Good.
But I am obtaining a user accuracy to 98.
Yeah.
But with the cycle solution, I've done something like this from the.
It's because in the confusion matrix, you also need to change the, can I see? Yeah, you also need to change, where is it? Instead of here, x values, and yeah, maybe we should, yeah. And now if you want to check like your confusion matrix, if you want to check the other evaluation criteria, you also need to use the new x train down slash s, this one. Or x train and for the validation, this one.
And training it more would increase the accuracy of the validation sample or not?
You can try.
Yes.
Yeah, you can try. The validation. It's okay that in the training set performs quite good in the validation also because it's a smaller. What about the dogs? Okay. Did somebody get lost? Does somebody need help? I got lost many times. Okay. Let me know. Tell me.
¿Por qué es importante para el X y no para el?
Vale, porque el Y solo es un label, solo es un 0 o 1, ¿verdad?
Ya.
El label, este Y solamente es 0, 1, pero este es o sea, los datos, ¿no? Los CLs. Bueno, en este caso no eran CLs, eran el Power Spectrum, ¿no?
¿Verdad?
Sí. Solamente se hace por eso. ¿Qué tal? Súper bonita, ¿eh? Vale.
This kind of organizations, you said before, shouldn't depend on the random state too much.
It shouldn't.
But if we are treating with noisy data, how much we can not depend
on the random state? Even if you are treating noisy data, if the noise is too high in comparison to the signal, you are not going to be able to detect or to differentiate in this case to, so if it's too noisy, either way, like independently of the random state, maybe your neural network is not going to perform well. But if it's like a reasonable noise, it shouldn't depend. Like you should just see a small variation that you can write as an error, like in the confusion matrix, instead of seeing, okay, no, I won't show you the rest. Yeah, here in the confusion matrix, instead of this, you can normalize it to the total and say this is 0. Whatever 5, 0.5 plus minus something, So this should be just the range of. So actually, this is a good practice to create trust in your results, right? Like it needs to be robust. But I know that, okay, how is it robust if I am fine-tuning the architecture, right? But the architecture is a different thing. Like the data should be robust, the signal should be something that you can detect in principle. Yeah. Tell me.
I mean, either it's like perfect to classify or like the accuracy was almost immediately one.
With the standard scalar, right? With the normalization. Yeah, yes, it's okay. This means that, okay, the message that I want you to take home is that sometimes we just care about the neural network, but it's actually 50-50, the work that you have to do. Like you need to care also about the pre-processing, which is the normalization. Okay, so not all the data, I mean, of course, this data that I showed you, you can in principle, like the CMB data, right? You can differentiate them, but the reality is not like that, right? So you need to do a bit more of data pre-processing steps so that the signal can be detected. Like it depends on the task. So maybe you're gonna find this in your scientific career, and you're gonna have to be able to learn different normalization techniques. I just showed you one that is this X mean, X max, and so on. So did everybody finish training? You can just tell me, no, I didn't finish, and we can give 2 more minutes. No? Is it okay? Okay. So maybe let's go to the next task, which is number 6. So I actually wasn't planning to touch this topic of early stopping, but you asked me this morning. So I thought, okay, maybe let's try to play a bit with it. So as I told you, early stopping is a technique for not overtraining. So you need to check the patience, right? This is the hyperparameter that is inside of this. They call it callback early stopping. How do you implement it? First of all, you need to import it like this from TensorFlow. I think it is already there in the, it's already there in one of the cells. So you need to import it from TensorFlow. It's literally called early stopping. And then I just wrote like an example of how to use it. So you define early stopping, and what do you want to monitor? The validation loss, the accuracy, you can change this. You can set your patience here, the parameter that we were discussing before. It can be 10, it can be 20, depending on the number of epochs that you have. So the patience is the number of epochs that you are going to have your accuracy to be constant or relatively constant, if that's okay. And then, okay, restore best weights, which means like, okay, wait, what was the restore best weights? Okay, I don't remember what was the restore best weights. I always write it. I'll explain you in a bit. Okay, so now you need to use early stopping inside of your model fit, which means, where is it? here, right? So you need to add, when you write model.fit, xtrain, blah, 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 callbacks, early stop, because we have defined it here, early stop, to the model fit. And then you can change the patience to monitor how long does it take to stop in the training process. And then you please let me know how many epochs are enough, like for your model to be trained. So this is the next part. Again, let me know if you have any problem. I think this should be already in the, right? It's in the collab. Okay. And I'll tell you what is the restore best weights. Okay. Let me know if you have questions. I can approach. How did it go? Yeah? Wow. And with what did you monitor? The validation loss? I see.
My class starts from one, I don't know what it was.
I think it's going up very quickly. Maybe because it's can you restore the how do you say, clear the session?
Ah, okay.
Maybe that's it.
Yes, because I'm clearing the session with PS errors again.
Yeah.
But still,
You have to click on the live again.
Yeah, exactly. Clear the session, compile again the model, and then do the model fit.
okay.
Aquí para el estudio, ¿cierto? Porque hay que seguridad a los.
Right? Domenico, maybe it was that you need to clear the session, then compile again the model, and then model fit, and maybe it won't go immediately to 1 because the weights will be set to random again.
Okay.
Ah, you already did that. Okay, okay. Okay.
Perfect.
No, I think, I mean, we did this together. So you know more than me, actually. I'm actually intimidated that he's here.
It is supposed to stop this when
Yeah, when you reach, like I just wrote validation loss, but you can write accuracy, validation accuracy, you can write loss, validation loss. You can monitor whatever you want, but in principle, should be more or less the same. Like,
because it went for all the 100 records. It is tough.
ah, really? Oh.
Maybe because it
Ah, wait, when you do the model fit,
yes.
did you add this callbacks? And it's not working.
It's like that one.
Well, that's just, yeah. Then it's one. Oh, no. 74. No,
Oh, no.
it's going on there.
Yes.
Can you check? Yeah, maybe something is wrong because you can see, or the patients, maybe it's too big. Maybe can you go, oh no, it's 8.
The best one too.
Interesting.
Ah, porque tengo batch size de 100 pisos.
Tal vez, no sé si, ¿cuántos es tu 62? 32. Ah, 64, 32. Maybe try that, but it shouldn't matter. Okay, I can check your code in a bit. How about the rest? Yes? Who already did it? Can you raise your hand? Okay. Okay, we can wait 4 minutes. And if you need me, just tell me, hey, yeah. Do you need me?
Tal vez. Sí, hacer ear session para cada implementado. O sea, lo que pasa es que cuando haces ear session, los pesos los vuelves a random. Entonces, y entrenas encima de lo que ya sí, entonces vas a tener menos épocas porque se supone que ya aprendí algo que son los que tienes que reiniciar la sesión cada vez, o sea, para poner los pesos como cuando se pasa la mayo. Y me dicen que tal vez porque lo ¿cómo?
Para la última ronda.
No, que tal, porque lo guardo, pero lo eso me está cansando bien. O sea, muy poco más. Es que la verdad sigue cambiando, ¿no? No consigo pasar los cero, pero mira cómo no, pero y si es otro número de pacientes 300, no, pues, pero no se ve tú. Eso es que es que entonces mi modelo es demasiado bueno. Eso es lo que está bien.
Y de hecho hay que hacer otro programa en base a con programación. Por ejemplo, con la
Sí, pero me puedo meter yo desde acá, ¿no? No, no está arriba, pues está en opción. Hay un brillo, ¿no? Ya,
Y en base a eso, sería como.
Y te dio un abrazo, pero si te vamos entregado el Dynamic
por eso
Tiene un brillo, como puede ver.
no, pero es. No, no, es la buena. Saqué del Letterboxd. ¿Lo ha hecho? Saqué la base de pero no a aportar en esta wea, pues no. Sí, pero hacer esta wea igual que ahora. Por ejemplo, este video wea. Cada vez, si en diciembre van a entrar wea, tengo que ir por
Sí, yo también.
esta wea. Tienes que primero hacer como un diseño, hacerle ver o sea, ya cualquier página, web, pero sería prácticamente como que o sea, comprar todo esto con los botones, como el tipo de una web página muy cualquiera. Eso sería o sea, pero claro, la dificultad es que, por ejemplo, cuando
How is it going? How many epochs did you need with the stopping? 21. 180. Wow. What about you? 68. What about you? 60. We can take the average of this. We can get a dispersion. Okay, 108, 60, 68. We can check 180. 90. 80. Yeah, it's a lot actually.
Does my value function keep?
It kept going down.
Yes.
I think for me it was. Did I even train it? Yeah, probably you're right. I don't even remember. Okay, so for me it also reached the 100. But okay, whatever. Okay. So let's go to the last task. So let's go to the last task. If everybody finished, yeah? Good. Okay. I'm just saying good, but maybe 2 people answered, so. Okay, so if you need any help, I'm also happy to help you, or to, like, we can check your code. I will be here also tomorrow, so don't worry. I know you're not worried, but anyways. And then the last task is another question that you asked me this morning, which is, which kind of optimizers do we know? Like, which is the, I don't know, best architecture for your problem? And for that, you need to use this package called Octuna. I think you need to pip install it in Colab first. So you just pip install Octuna, and then you import it. And once you install it and import it, you need to run this cell. So what am I doing here? I am defining a function for the trials that we're going to perform. So what Optuna is going to do is going to take, I just define my model, 1 layer, 2 layers, 3 layers. So my hyperparameters that I'm going to tune with Optuna are going to be the number of neurons in the first layer, the number of neurons in the second layer, and it was also the learning rate. Yeah, here, you see? So these are my 3 parameters that I'm going to fine tune, and also the batch size, sorry, 4 parameters. But in this case, I just wrote 32, 64, 128. Like, you can go lower, you can go bigger, but this is more or less the standard. So you define this model, you define this function, the parameters, you define the model, you compile it. And here, I also called early stopping so that we don't have to overtrain, that we don't have to take so much time. Here, I also monitor the validation loss. I set the patients to 10. Okay, and this restored best weights, I already know what it is. So if you are, for example, setting your patients to 10, this means that you are going to monitor the accuracy for 10 epochs, and if it doesn't change, then you stop, right? But the thing is that in these 10 epochs, the weights are going to be updated, So you are taking the best weights from the first part of these 10, from the batch of these, like, how do you say, from the first realization of these last 10, let's say, so that you don't have to update the weights again, all these last 10 passes of the data, let's say. Does that make sense? Yes? So, and then the last, we do the model fit as usual. You define the number of epochs, the batch size. Now this is a parameter, right? And yeah, we define the model, the function. And finally, we create a study. So Optuna has this option, create study. So you maximize whatever you are monitoring, I think. Okay, I need to check what exactly was the maximize. But anyway, so what you need to do is, where is it? Study.optimize, and the objective, it's our function. Okay, so the study.optimize, the objective, which is my function, and I tell it how many trials I want. So in my case, I'm just writing 15, but usually people do 100 or 200, to see what is the best, what is the best number of the hyperparameters that you are trying to find. So you can run this. I think here it says Yeah, after the normalization, run the cell, change the patience, which is the best suggested architecture.
Patience goes to be optimized.
Yeah, it could. I guess. I have never done it, but I guess. You can also optimize the number of layers. Like here, I just wrote 2 layers, but you can also make it a hyperparameter and say, how many layers do I need with how many neurons each, you know?
Using this tool, how we can avoid overfitting? Or it is like a kind of optimization that is always used?
Yeah, this is actually a good question because sometimes, for example, you have the accuracy, which is 0.99, 0.98, and I told you that you have some fluctuations, right? So I would, personally, what I would do is that I would take the architecture that seems to be like reasonable, meaning that it has the less amount of complexity, that it still gives a high accuracy. I would do that. So run please the cells and let me know this, which is the best suggested architecture. And you can also change the patience, play a bit with it.
Pero entonces va haciendo trials random o como en base al trial anterior, como que sigue el siguiente.
Pues lo que él decía, que yo no sabía, era que es como hacer un MCMC, que haces como una optimización. Yo siempre pensé que, sí, yo siempre pensé que era random, pero
Sirve también para regresión, ¿no?
no estoy segura. Nunca lo he utilizado para regresión. Te mentiría. Question.
I mean, I don't know what is like, see what I learned, you have, yes, and that the values are not done. But values are.
The values of the, for example, of the amounts of neurons, okay?
Are they wrong?
I thought that they were random, but we have a discussion here that it was based on an MCMC, you know, that you can find like most optimal.
But it's not like it's like a something for new program, because as far as I understand, like there is like a type that you can use like dilution optimization. They start with random classes, and then they are like find the best ones based on like I'm not sure how it works. I don't remember, but they are initialized as random. So
Yes.
is the one.
I mean, in principle, they are initialized as random parameters because, I mean, now I by hand said that my model is going to have only 3 layers, right? One input, one hidden, and one output. But you can also make that a hyperparameter, and in principle, that would also be initialized randomly.
Yeah.
And you can have as many parameters as you want. But in principle, they are all initialized randomly.
Yeah, yes, but my other question is it really possible to access this
I am not sure personally. I don't know. I thought they were all random, but I am not sure. Yeah, because also thinking about it, it would be too chaotic maybe. I thought that they were all random, but it would be maybe too chaotic to just take random combinations. Maybe they want to explore maybe a bit the parameter space, the hyperparameter space in this case, right? So that you want to reach to some, yeah, maximum accuracy or something like that. Yeah. It's interesting questions. You have me like, I don't know. Sorry. Okay, so yeah. Tell me. I'll take this one and I'll take yours.
When we use this kind of functions or tools, this kind of session clearness that we
Yes.
at the beginning, then it's automatic.
Yes, because there is an option. In principle, yeah, yeah, restore best weights through. No, sorry, that's the early stopping. Sorry. In principle, yes. I mean, because Optuna shouldn't use the previous, right, trained model. So yeah, in principle, yes. Sorry, and you had another question. I forgot. Yo también. Aprendemos
I can say something about Optuna. We can specify that Optuna will use quasi MC sample. We specify that it's a quasi MCMC. It's not MCMC, but we can use quasi MCMC. But yeah, we should specify this not this.
Yeah, makes sense. I mean, when you guys were mentioning about like, yeah, it makes sense, right? You are like,
Maybe there are other optimizers using
that's exactly what she was saying.
but we can specify the quasi Monte Carlo.
But you can.
Pero no lo mismo. No, esa pasada les voy. Ese es claro, dice. Como las ancianas.
Hay dos.
Yo también hablo con ustedes.
Indira,
Sí, dime, porque
what is the acquisition function? But it has to be something like.
So we were discussing that, I don't know if this is related to your question. Maybe. So we were discussing that this is like the quasi-MCMC method, and it is based on something called TPE, which is, what was TPE? Trip.
Yeah, I was looking for something similar, and one of the samples is the also processes. And it's so that has this function for that. So-
Yeah, I also don't know, I'm sorry.
But
I was in the word here, right here. Yeah, but I mean, what I did all the time was just to use it like in the default setting. But maybe you can find tune many of, for example, the sampler. For example, this is supposed to be CNC, of the Korean CNC declaration. But the thing is that you can, yeah, modify. I don't know, yeah. I have never done it. But it's actually very interesting.
También se da la opción de usar el
Okay, so
Claro, yo no también puede ser, bueno, pues.
people here are super clever. That's really cool. How is it going? Do you have best suggested architecture? Can somebody share? No? Nobody wants to tell. This is the last part, and then you're gonna be free. I promise. Just please share. You here? You wanna share? No, just tell me.
Well, varies when each every session. But for this time, it says something like 48 euros the first layer.
40.
2 in the second, and a size of 30.
Okay. What about the learning rate?
6 times 10 to the minus.
Okay. Okay. I mean, fair enough. I don't know if I run it actually.
I got a lot of neurons, like 112,
Oh, wow.
and 6 inside batch. But times 10 to the minus 4.
Yeah, those are a lot of
Batch size of 32.
so what I did, because there's also like some randomness in this process, right? Like I tried to run it several times and try to compare like Okay.
Setting a higher patient will be like more reliable.
Yeah, that could work actually. Because 8, I set it to 8 and that's maybe too low. But because it's just to show you, so that you don't take years to
Yes.
train every time. But maybe you can set the patients to like whatever 50, and perhaps the whole epochs to something like 100 or something like that. Could be more reliable, yeah.
Another thing, we see in this example that using Octona, we try different visualizations with similar value of accuracy. And
Yeah, exactly.
how much or how different, how useful could be for bigger networks?
Yeah, I mean, actually, you use Optuna usually when you don't know which, like, you know that there is a problem with your architecture. Let's say, okay, in my case, I checked my data. I checked the simulation steps. I did the normalization steps. I tried to see absolutely everything, and my network is still not performing good. So I want to give it a try and try to see which one could be the architecture. Maybe I'm not using the architecture or something similar. Like, for example, if I'm using just one layer and then it suggests me 7 layers, then maybe I'm a bit far away from I'm far away from the most optimal. So I usually use it for exploration of architectures when I know that everything else is working and it's just this the problem, you know? Yeah. If that makes sense.
I have a question, maybe not right for Fortuna, but well, would you want to add more layers of neurons? Like, because we're using 2 now and it's working great.
Yeah.
What would you want more than?
Okay. So the idea is that because now we're having just tabular data, right? It's just data points. It's easy to generalize in a sense. We can even see the differences between the models, right?
Okay.
But whenever you have, for example, images, then that's a bit more difficult because you are dealing with pixels.
Okay.
And the pixel has, like, I don't know, some filters, some numbers, like you need to encode this image into some numbers, into some matrix of numbers. And then this matrix, because it's not just a one-dimensional array, it's a two-dimensional, right? So you need to lower the dimensionality of this. And then again, so usually when you deal with images, you would need more layers. I think usually you need the CNNs in this case, for example, like which are convolutional. It's a different approach, but yeah, but based on the same principles. Well, I think we are done. In case you want to ask something else, no, maybe you're super tired. You just wanna go. No, but yeah, I think it has been very good. Thanks. I see that you are very interested and you are trying to catch everything that you can. You're even asking me questions that I don't know how to answer. But thanks for that as well. So see you tomorrow at the same time. Okay? Okay.